In today's video, I want to show you a really nice strategy we can use to write the electron configuration for atoms, and that involves using the block method of our periodic table. So what I mean by that is we're going to divide our periodic table into quantum blocks. So let's look at group 1, hydrogen plus all the alkali metals, and group 2, which is beryllium and all the alkaline earth metals. This section of your periodic table is called the S block. What that means is any element that falls in group 1 or 2, its quantum electron configuration will end with S. So we know that S, by the way, that it can hold a maximum of 2 electrons. So if I'm in the very first group, like hydrogen, lithium, sodium, etc., its electron configuration will end with S1. If I'm in group 2, like beryllium, magnesium, calcium, and so on, its electron configuration will end with S2. Now, how do I know what orbital it's in? That's where the period numbers come in. So for example, hydrogen ends with 1, S1. Lithium would end with 2, S1. And then beryllium, its configuration would end with 2s2. Okay, so we're going to do a full example in a minute, but that's how this sort of works. Now helium, by the way, although it's all the way on the other side with the noble gases, helium is also part of the S block of elements, so I'm just going to kind of label that one there. And helium, it's in the second position over. I know it's not in group 2 officially, but helium would actually be a 1s2. Okay, the next block of elements is the P block. And that goes from boron to neon and everything under it as well. Okay, so the P block is like this. So again, in terms of my, my strategy, boron would end with P1. Okay, it's the first element in that block. Carbon would end with a P2, nitrogen a P3, oxygen a P4, fluorine a P5, and neon a P6. So again, what orbital or what principal quantum number would they be? There's no such thing as 1p, so the P block starts at level 2, so that would be 2p. Aluminum and everything across there, that would be 3p, and then 4p, 5p, 6p. Okay, now let's look at scandium to zinc. This section of the transition metals is called the D block. Okay, so again, meaning any element that falls in this segment ends with an electron configuration of D. So if I'm scandium, I end with D1, titanium, D2, and so on and so forth, all the way up to D10, okay, because the D block can hold 10 electrons. So why did I label the D block with these numbers? Well, there's no such thing as 1D. So where you see scandium, that cannot be 1D1. There's also no such thing as 2D, so it cannot be 2D1. So if you guys remember from quantum, the D block starts at level 3. So scandium would end with 3D1. Titanium would end its electron configuration with 3D2, and then so on and so forth. Now, at the bottom, I'm not going to maybe go through this one in this video, but we do have our F block of elements. And again, in terms of F block, there's no such thing as 1F, 2F, or 3F. It starts at level 4. But we can maybe talk about that another time. So let's just focus on our S, P, and D blocks and do an example. So let me actually pick an element here. So let's do carbon. Okay, so let's look at a carbon atom. So carbon, the atom, what is its electron configuration? So to do the block method, you always start at hydrogen. So we always just start at the very beginning of our periodic table and count chronologically upwards till we get to the element that we're working on, or the atom we're working on. So for example, hydrogen's a 1s1, so I'm not at carbon yet. So we're going to go over to helium. Helium is a 1s2. Okay, so let's write that down. This is so far a 1s2. I've maximized my first orbital and my s orbital. But we're not going to stop there because 1s2 is just helium. So let's go to the next line. So let's look at period 2 where we see lithium and beryllium. So again, lithium would be a 2s1, beryllium is a 2s2. So we need to write that down. We need to maximize our electron orbital, 2s2. Again, we're not going to stop there because if I just wrote this, the answer would be beryllium. So we're going to go across on our periodic table and look at boron and carbon. So now carbon is in the P block. I know it ends with P. So to be specific, it'll end with 2p. Now because carbon is the second element over, it'll end with 2p2. So the full electron configuration for carbon has 6 electrons, an atom of carbon has 6 electrons, is 1s2, 2s2, 2p2. Okay, now we could also do the noble gas version of this, which is the abbreviated electron configuration. So if I pick carbon again, to do the noble gas version, what you do is you go to the noble gas that's closest to carbon, so that the one that's actually before it. So in this case, the closest noble gas before carbon is helium. So we say square bracket helium, so that means carbon has the same electron configuration as helium, but we have to keep going. So with an additional 2s2, so lithium and beryllium, and then go across again, 2p2. Okay, that's how we do electron configuration with our block method. So maybe let's pick a different element this time and maybe pick a element with more electrons and see if we can get the gist of it. So let's pick something, let's pick nickel. Okay, so that is atomic number 28. Nickel the atom, okay, not the ion. So nickel the atom. If we do the full electron configuration, remember what I said before, start at hydrogen. So hydrogen to helium is 1s2. So we're still quite far away from 28 electrons. Let's go to the next period here. So lithium to beryllium is a 2s2. And then we're going to go across into the p block. So boron, carbon, nitrogen, oxygen, fluorine, neon, that's 2p6. Again, we're still not even close to 28, so let's go to period 3. So between sodium and magnesium, this is 3s2. We're going to go across to the 3p block, and we're going to have to count all of these elements and all of these electrons. This becomes 3p6. We're going to go to our next line, 4s2. And then we're going to go, remember, the D block starts at level 3, so it'll be 3D, 1, 2, 3, 4, 5, 6, 7, 8. Nickel ends with a 3D8. And notice, yes, the D block comes, 3D comes after 4S. That has to do with our Aufbau energy filling principle. So you'll see that the block method, it will put your electron configuration also in the correct order based on Aufbau. Okay, so let's do nickel again, the atom, using the noble gas configuration. Let me clean up a little bit of this process work. So again, we're going to look for the noble gas closest to nickel, the one that comes before it, that would be argon. So nickel is square bracket argon, and then let's count forwards. Then we go here, right? This is the level 4, or sorry, period 4, it comes right after argon. So it'll be argon, 4s2, and then go across 3D, again, we're in the D block now, 3D, 1, 2, 3, 4, 5, 6, 7, 8. 4s2, 3D8. That's the noble gas version of nickel, the atom, its electron configuration. Now, this block method is also really handy for ions, so it's a great strategy to use for electron configuration. Hopefully this made sense. Let me know if you have any questions in the comment section, and thank you very much for tuning in. If this helped you at all, it would be great if you could like and subscribe. Thank you so much.